In our discussion about sliding windows, let's start with the problem number one. The first problem that we are looking at is this problem called the sub-array sum. Let me discuss this with an example, and then we'll see several applications where this problem comes up in real life. So the problem statement is given a list of numbers. These numbers could be positive, negative. The list may not be sorted. What is the maximum or minimum sub-array sum among all the contiguous sub-arrays of length k? So let's understand this carefully. Given a list, for example, like this L, now a sub-array basically is any contiguous set of elements. So for example, if I were to say k equals to 3, I'm looking at sub-arrays of length k, length 3, which means that I'm interested in looking at these sub-arrays, for instance, 3, 2, 1, 2, 1, 4, 1, 4, 2, 4, 2, 1. You notice the interesting the sub arrays of interest basically are those where the items are contiguous. That's why I'm not looking at, for example, 3, 2, and 4. That is not a sub array to me. But 3 to 1 is, 2 1 4 is, 1 4 2 is, 4 to 1 is, and so on. So my question is, amongst all of these sub arrays, which has the largest sum, or perhaps let's say the smallest sum? Now, this is a problem we are going to solve efficiently using a fixed size sliding window. But of course, we'll develop this slowly. We'll first look at the naive algorithm and then we'll go to the sliding window part. Before going there, however, let's look at some practical implications of this problem so that we kind of get a better feel for it and a better connection with, let's say, the real world. Let's say we are looking at a stock price of a company's stock for, say, last 1000 days or last some number of days. We may want to find the moving average. In fact, moving average is a very important metric in analysis of stocks. Basically, for example, average price of the stock every contiguous 5-day window, because then we can tell about how the stock has been, let's say, performing. Another application is that, let's say, we want to analyze the traffic at a particular busy junction in a city. So we have data from that city, that junction, that okay, look, every hour this many cars go past. Now we may want to find the busiest or perhaps the least busy 3-hour window, maybe least busy because if, let's say, we want to plan some work, perhaps we can plan it there, maybe from a city authority's point of view. We can look at the runs scored by a top cricketer in every match as a list. And then we can ask, okay, look, what is the best 10 match period that this player ever had? So you can look at your favorite, for example, cricketer, maybe, whoever you like, and you can say, okay, look, in his entire career, these are the runs scored. What was the best patch that this person had? And again, that's a problem of basically sub-array sum. You can apply this also to other sports. We can also have temperature or any kind of other weather data from a city, and we want to say, okay, what is the hottest, let's say, 6-day stretch, or maybe the coldest, right? Or perhaps the most humid, or most, let's say, or say the most rainfall. So you get the idea that there are so many practical implications of this, problem. In fact, I suggest that to make this interesting, look at a data that is of interest to you. Could be stock data, could be, let's say, traffic data, could be sports data, could be weather data, whatever appeals to you, apply the ideas there, because then the entire experience will be that much more enjoyable to you. We are going to come back and look at solving this problem first in a naive way and then through a smart sliding window method. But that will be in a future video. I hope you found this interesting. As always, at YByte, we learn programming in a way that is fun, that's engaging, yet that is rigorous. Do look at our website, www.ybyte.in, and forever enjoy coding. Take care. Thank you so much. Bye-bye.